So this question involves your trig function, so your sine function. So part A says, photocopy the above graph, so y equals sine of x, for the domain of x between 0 and 2 pi, and on it, carefully graph the line y equals x minus 2. So that's what we're going to do. I'm just going to quickly draw this graph, and I want you to do the same thing, okay?
Yeah.
So what I'm going to do is, because my domain is between 0 and 2 pi, this is 0, right? I'm just going to call this 2 pi. I'm going to half that roughly here is pi, and half of that is pi on 2, and half of this is 3 pi on 2. Okay. Now, you know, for your sine curve, you know that the amplitude is 1, so I'm also going to put that in. So sine starts at 0, right? It hits the x-axis at pi and at 2 pi. So I'm just going to do the graph in red. Starts at 0, reaches a peak at pi on 2, and then hits the curve at pi. And then comes down, it reaches a trough at 3 pi on 2, and then hits the curve again at 2 pi. So that's pretty much what they've drawn up there, okay? So I'm just going to carefully trace the sine curve, something like that, and then it comes down again, hits the curve, hits the x-axis at pi, comes down, reaches a trough at 3 pi on 2, and then comes back up to 2 pi. So that is your sine curve with an amplitude of 1, okay? So it's got an equation, y equals sine of x, correct? Great.
Yeah.
So next thing they want us to do is also draw on this curve the line. I'm going to do this in green so you can see the difference. So we're also drawing the line y equals x minus 2. So what kind of line is this? Or what kind of curve is this?
I don't know.
All right, it's a linear function because you see the power of x is 1. So this is just going to be a straight line, okay? So,
okay.
So what we're going to do is we're going to graph this straight line on this curve, right? So what are the two most important points on a straight line? What do you think?
Just the y and x-axis. Well, where they hit the y and the x-axis.
Good. So the y and x intercept, and that's usually the easiest way to graph something. So what is the x intercept of this curve?
1 second.
All right. So x. Yep.
The 2.
Yeah. So x intercept is when y equals 0. So we sub in 0,
yeah, so
we get x minus 2, so we get x equals 2. Good. So the x intercept is x equals 2. So then I'm going to ask you, where about is 2 on this axis here? So roughly, yeah.
So it's between pi on 2 and pi.
Well, what's pi on 2 roughly? So pi on 2 is roughly 1.57, right?
Yeah.
And pi is roughly like 3.1, correct? So
yeah.
2 would be somewhere here.
But yeah, closer to pi on 2.
Yeah, closer to pi on 2, but still in between. But yeah, closer to pi on 2. So 2 would be roughly here. So this is the x-intercept of the curve, correct? And what would be the y-intercept of this curve?
So that's when x equals 0.
Yep.
So it's just going to equal -2.
Yeah, so this value is
equal
your y-intercept. Yeah, y equals -2. Now, y equals -2, what I'm going to do is I'm going to try and extend my curve here. My axis, sorry. So if this is -1, then -2 would roughly be here, correct?
Yeah.
Is that right? So then -2 would be here for the y-intercept, right?
Mm-hmm.
That's great. So now what's the next thing we do to graph this straight line? What do you think?
Just a line which both points have to be on it, basically.
Yeah, so it's a line where that hits the y-axis here and hits the x-axis here. So I'm just going to use this one to sort of help me get like a perfect line. So it's going to intercept the y here and intercept the x here, just like so. And I'm just going to extend it up to here just a little bit. So it's a line that looks like this, correct? Yep.
Just a sec.
Yep.
X minus 2. Yeah, okay.
Cool. Okay, so that's part A done. Then for part 2, it says, use your graph to estimate to 2 decimal places the value of x for which sine x equals x minus 2. So that's interesting. So I'm just going to rewrite the question here. So part B. So it says find x when sine x equals x minus 2.
So
Okay.
in part A,
Yeah.
or in part 1, where it says y equals sine x, would you just sub sine x with x minus 2?
Yeah, that's exactly right. So yeah, that's actually right. So what is this showing? This thing here, like sine x equals x minus 2. What do you think it is?
Sine x equals x minus 2.
If you think about something, so let's look at the left-hand side. So the left-hand side is sine x, correct?
Yeah.
So how does that relate to the first part?
That's the function.
That's the function. Okay, keep that in mind. And then the right-hand side is x minus 2. How does that relate to the first part?
Because that's our linear function. There's a median point.
So it's 2 functions.
Intersection.
So sine x is your first function. I'm going to call it y1, and x minus 2 is your second function, right? That you grab.
Yeah.
So what does it mean when they're equal? How would you say that in words rather than writing it algebraically like this? What do you think? It's when you equate 2 functions, what does that mean? Think about it.
If you're going to equate them.
Yeah, well, when you equate 2 functions, what are you trying to find by equating 2 functions?
X, in this case, x.
Well, but what about the x? What's so special about this x coordinate?
Aren't you trying to find what it equals? Or so wouldn't it be like you're trying to
but
find where they both intersect on the graph?
That's it. So when you equate 2 functions, you're finding the point of intersection.
Okay.
Correct? There are 2 ways to find a point of
intersection.
intersection. Yeah, just write that down. That's fine.
So also when you equate 2 functions,
yeah,
you want to find the point of intersection.
That's correct. Always, right? You always do that when you want to find like a point of intersection. So so this question is no different, right? Keep that in mind.
Yeah.
And another thing that gives it away is it actually says to use your graph. So the moment you see this algebraic equation, it does look very, I guess, scary, but it relates to the first part in some way, so you should really sit there and look at it and try to think, how can I use the first part to answer this question? And which you did, you realize that the left-hand side was one function and the right-hand side was our second function. And then so once we equate those 2 functions, it means, in other words, we're finding the point of intersection. Now, in order to solve for x, we can do it 2 ways, essentially, in maths. You can do it algebraically, so by making x the subject of the equation, or you can do it through graphs, right?
Yeah.
Now, in this case, if I gave you an equation like this, it'd be really hard to solve it algebraically. You can't just use your standard algebraic skills, which is why we have the first part. So instead of using algebra, we're going to be using the graphs to find the point of intersection, so which is x, right?
Yeah.
So you go back to your graph, and where would the point of intersection be, roughly, do you think? Well, I'm going to ask you a question first. How many points of intersection, or how many points of intersections are there between these 2 functions within that domain, between the domain of 0 and 2 pi? Yeah, exactly, just 1, right? So sometimes the question can ask you, how many solutions are there? Solutions just means x-intercepts or x values, right?
How many? Okay.
Yeah, but sometimes it asks you just for how many. It doesn't want to know the actual value of it. It just wants to know how many are they. So in this case, it would be one solution because there's only one point of intersection over here, right?
Yeah.
But if you reread the
Yeah, that's
question,
right.
if you reread the question, they want you to find the actual value of it.
Yeah, the value of x.
That's correct. So what I'm going to do is I'm going to draw a dotted line down to the x-axis. So this is where it intercepts the x-axis here. Right?
Mm-hmm.
So now you have to approximate, right, to 2 decimal places. What do you think is the value of this x-intercept or of this x value?
Well, it looks around 2.5 or a bit more than 2.5.
So what would you say? 2 point,
like 7-ish, 2.7 or 2.6.
What about to 2 decimal places?
Oh, okay. So it could be like 2.75, for example.
Yeah, that'll do. Another way that you can do this, and I think there are multiple answers because it just depends on the way that you've drawn the graph and the way that you interpret it, right? Another way that you can do is, to me, it looks like it's halfway between 2 and between pi, right?
Yeah.
So what I can do,
Okay.
yeah, so what do you think you can do now?
Well, if it's halfway
Yeah.
between 2 and pi, you want to find, wouldn't you want to find what pi would equal something, or?
Yeah, or you can just do it like this. So if you want to find the midpoint between 2 and pi, you can add them together and then divide them by 2.
Yeah.
So 2 plus pi divided by 2. And then you put that in your calculator. Yeah.
It's 2 decimal place?
Yeah.
2.57.
Awesome. There you go. So we got 7.5. Like I said, like there are multiple answers because it's just the way that you draw the curve and the way that you interpret it. But it should be around 2.5, you know, give or take.
Okay.
0.5 or so. And that's it. So we would say that approximately x equals 2.57. And there's only one x value because there's only one solution. They only intercept once between 0. Yeah, they only intercept once between 0 and 2 pi. And that's the answer.